was about the production of these unconventional gases. In Australia, the main method we use is hydrofracking. So we simply fracture the reservoir in the same way that we might hydrofrack a petroleum reservoir to increase production. That's the main technique we use in Australia to get better permeability. Coals. Permeabilities are generally terribly low, between 1 and 0.1 millidarcy. Permeabilities are quite common for in situ coal seam gas plays. And so we hydrofrack. There's another technology called cavity completion that's been used very successfully in the US to increase permeability and get better production rates for this.
So we have also so just maybe a technical
Technical question. We saw a photo. You said that it's multi-complete and here. How can take this picture?
It's a model. A model.
Model.
Not a photograph.
So
It's a computer-generated model.
Yeah. Another question may be related also to the same. What's the better method or the microscopic study for study of coal? I mean, just report about 10 angstroms. You need the scanning of the microscope.
Low angle X-ray diffraction sorts of studies, NMR studies are very useful for looking at the structure of the coals. Dirk, other things you would like to use?
Yeah, for sure, tomorrow we have done FRB-TRM. So there you can see the porosity. You can see really from the air, so what we have done. And we have measured with low pressure absorption techniques, X-ray diffraction, Newton scattering, and it's really consistent.
You can explain tomorrow?
Yeah.
Tomorrow,
So you can see
official signal about it.
Sorry.
Because they can take pictures of them. Allah.
So it's a very nice presentation and interesting. I have 2 or 3 questions regarding the storage of gas during the coal. You talked about the kind of porosities, which was micro, meso, and mega. Okay, for example, the micro is about 20 strong. Here I have to ask about the weightability of coal. This coal has a kind of weightability for example, water, or no? Because within the coal, if it is about 20 strong, and a water molecule, which is about, let us see, about 3.2 angstrom, if the coal is water weight, that means you have no any more than 10 strong porosity space for storage of gas methane, which is about 3.8 angstrom.
The issue with water is quite interesting because water, you're quite correct, the size of the water molecule is about 3.2 angstroms or thereabouts. But water doesn't like to hang around by itself. Water likes to form in little clusters, and you normally get at least 3 or 4 water molecules clustering together.
The question is about the weightability. If the coal is weightable, or is water weightable, even in the deep buried locations, still there are about 1 or 2 monolayers of water.
No.
Yeah, if you want. The point is that what is saying is sorry. I will show you this tomorrow. Water tends to cluster. So normally you have water clusters between 8 and 12 molecules, and even the correct collision diameter for water is 2.8 angstrom. So they're forming clusters which has the size of about 7, 8, 9 angstrom. And a lot of the porosity which the absorption takes place is below 4 angstrom. It's about below 4.3 angstrom about. This is the so-called ultra microporosity. And in this pore space, water is not able to come in. So there is, even if the coal is water saturated, there is a lot of porosity left. And this is quite, for example, also different to activated activated carbons or so, which have normally porosity, let's say, between 1 nanometer and 2 nanometers, about 2.5 nanometers. The adsorption porosity in coals is the porosity below 0.5 nanometers, so 5 angstrom. And tomorrow I will show you this from the experimental data, and also you can visualize it from, like I said, with this FRBTM. And so there is a difference if you have a dry coal or a moisture equilibrated coal in porosity. But the remaining porosity is also the effective porosity for the adsorption of methane and also for carbon dioxide.
Okay. I have another question, please. It's about the gas storage mechanism.
Just a minute. Yeah,
I think there was a slide about the gas storage mechanism. I noticed, I think it was the second point, which is there is an equilibrium between solid and gas, which is, you mentioned it is reversible.
Yes, it's correct.
You mean reversible between gas and liquid?
Now, I mean, when you do an adsorption experiment, you get a curve that goes up. If you do the desorption experiment, the curve tracks back down the same line. There's no hysteresis, or very, very small hysteresis, between adsorption and desorption.
Because what confused me was solid and gas.
Between the solid and the gas, there's no hysteresis involved in adsorption and desorption in the solid coal, and the gas absorbing onto the solid coal, then the gas desorbing off the solid coal if you reduce the pressure. So you have okay, so if you have a plot like this, where you're doing an adsorption experiment, you're increasing the pressure, you're increasing the amount of gas absorbed by the coal. You come to the end point here, you start reducing the pressure, coming back in the other direction. The curve basically goes down exactly the same curve. So there's no hysteresis involved. If there was a hysteresis, you'd get a different shape curve, perhaps like that.
Okay, zero is reality.
Well, we do evacuate the systems. Whether it's exactly zero or not is probably a debatable point, but it will be close to zero.
Because zero pressure.
Well, it's not a reality. It's simply
It's a model.
The first data point is really here. They're simply projected back through the origin. The data's projected back through the origin.
Maybe last question. Why you start with thermogenic gas? Why you did not start with biogenic?
It does start with biogenic gas, and I didn't make that as a point. There's very early biogenic gas formed, of course, right from the peak stage all the way through up until you get to about 50 to 60 degrees temperature when the bugs are killed off because they can't survive the temperature anymore. So that is really the first stage of gas formation. That very early biogenic gas, though, was never preserved. Certainly the peak stage gases really aren't preserved. Maybe some of the ground coal gases are, but they generally escape.
Because what I also noticed that you talked about thermogenic gas and you said maybe sometimes when there were some kind of uplifting, this coal comes up and may contact with some kind of material and biogenic gas starts.
Yes.
But that is in the beginning also the same. And maybe there's some kind of uplifting.
Yes, that's right. During burial, you'll get the thermogenic gases form, the biogenic gases forming. As you keep burying, the bugs will get killed off because of the temperature. And then as you uplift, you'll come back into the correct temperature regime where the bugs can start growing again. And you'll start getting the biogenic gases forming a second time.
Okay. Okay, we have 15 minutes left. Thank you very much, John.
Thank you.
15 minutes rest, to coffee rest, and then we start with the break. Thank you. 15 minutes only.
Thank you very much. بأنت بشريان صباحا ولو Good afternoon, friends. I hope we will talk about the correlation. You know, correlation is it's an old method for comparison between or among different sections using certain things, certain like body fossils, like elements, like such kind of parameters that can be used for correlation. As in this seminar, we will talk about one type of correlation which is based on geochemical results or geochemical parameters. Geochemical parameters exactly are biomarkers or geochemical fossils. That's, as you know, these geochemical fossils as called or biomarkers are a very good indicator for different issues or the comparison between or among different types of sections or oils or hydrocarbons. So the geochemical correlation may be done by or using general or bulk parameters, or can be focused on one type of geochemical results which are biomarkers. Now in this seminar we will talk or explain about the second one, which is geochemical fossils. The relation may be established using or done by oil or oil source or gas source correlation. So these methods or these techniques can be used to correlate. If we have a different oil from different areas, we can compare between these two oils. Or otherwise, we can compare oil with source rocks for knowing if these oils came from these source rocks or maybe not. So the objective mainly is, can be in this seminar can be we will do on one rock units in Kurdistan or in Iraq, which is late Jurassic Early Cretaceous Chiagara Formation. This formation is selected for this study. So the geochemical screening of late Jurassic before, if we don't have results, we can't do correlation. So first, we will get results or data from source rocks or from oils, and later on we will compare these results depending on different parameters. Characterized extracts. That's what I mean. So you should extract the biomarkers or geochemical fossils from the rocks or oils, and later on you will describe or you will compare or you will use one of these correlations and this method. So the location studies or the samples were taken from the different wells, 4 wells selected for this study, and 5 oil wells. These are exploration mostly wells which are penetrate to the Jurassic and the lower Jurassic rocks. We select late Jurassic Early Cretaceous rocks from this, and we have 4 wells, and we have 5 boreholes in this study. The structures or the stratigraphic column of each well is described here in lithological description. We have from the boundary parcel information here in Cape 109 to Caribbean, and later on, the extraction of geochemical fossils is not easy. It's a hard work. It's taking times and cost. So it is not. It's not in our course, or it is not. We didn't all analyze all samples. We select several samples. These samples from each well and see the results or the analysis from this or these sections. The first thing to do is to calculate or to determine the total organic carbon from each samples by LICO 400 instrument. And later on, for organic content, the results are total organic carbon is about 0.6 to 7.4 weight percentage from different areas or from the different sections. So the potentiality we have fair to excellent. The total organic carbon also can be used in these sections. You saw here the distribution of total organic carbon in different sections. You saw that the lower part are much richer in total organic carbon and upward decrease, except in well Hamreen, which is nearly constant along the section of Chagara Formation in this area. So that's what I mean by geochemical correlation. These data also can be used for correlation. If it is total organic carbon, if it is elemental analysis like carbon, like nitrogen, sulfur, or vanadium, nickel. We published a paper about elemental geochemistry before a month. So the elemental geochemistry, in this section we have, in this diagram we have only for carbon, nitrogen, sulfur. Also we can see the results. The lower part is much more richer in these elements. That's why I will not focus on these elements because our target was geochemical fossils. So that's why we need to extract these rock samples for biogeochemical. And also, we studied the samples from the oils, crude oils, from, as we talked about, 5 samples from each well, and later on, we analyzed them for biogeochemical analysis. You know, biogeochemical analysis or geochemical analysis, you need to use GCMS for determining the biomarkers or the distribution of these biomarkers within these samples. And later on, you will compare these with each other. So different types. This is just an example of the data. How can we? I'm sorry, the table is not clear exactly, but I put it just to know that the work that you need for this analysis. I didn't talk about the separation of how can you prepare samples for GCMS runs. Also, it's a long way, and maybe some of them know about the procedure. It's just this the results of a normal alkaline M/Z85. The results is from carbon 14 or from the chromatograms, and you have the data from H-Chemstation software. You can use it. Later on, the isoprene also when you get the chromatograms, you will find many work to do on these diagrams. Diagrams, you can calculate the area under the peaks, and you can compare many different compounds or species in these chromatogram. Just like the chromatogram here, we have for hopanes or distribution of hopanes on the MZ mass overcharge 191, which you can identify the all compounds from 30 alkyl beta and all different isomers. Exactly, indeed, it is not easy to be common with these chromatograms, especially it's nearly new for us. Just the last 10 years we have working on these data, and recently we get some interpretation of how to interpret these data. Otherwise, all samples will sent outside, and later on the results will come back. So we learn to how interpret these peaks and identify, and later on how to calculate the area under peaks to compare these compounds, and how to identify isomers if it is tetracyclic, tricyclic, or another pentacyclic. So these are just for your knowledge that the homohopane index, you can calculate these parameters from each chromatograms. So you have the sample, you have the results, and you will you start to for calculating the area. For tricycle terrain challenges, you can calculate you calculate them, and later on, for example, in one of the samples of Henry, the ratio of carbon 39 sensitive vaccine over sensitive dextral types passing maturity. Another part, as we talk it, all are most aliphatic. Yeah, it's aliphatic stealing, okay. And aromatic, also, you know, we can, most of our aromatics are sulfur-rich aromatics, like benzodiazepine, dimethyltryptamine, naphthalene, and triaromatic and monoaromatic steroids have been recognized in this section. So I will discuss this each compound, naphthalene, phenanthrene, dimethyltryptamine, all are where it is looking about NZ 128, and each one has a special M over Z to be identified. Later on, it's just a sample for how can aromatic be described on 213. One aromatic will be here, and diaromatic will be here, which is common. Later on, one of the other aromatics are methylphenanthrene index. Methylphenanthrene index is also can be calculated from this equation when you will identify methylphenanthrene in this 3 methylphenanthrene over phenanthrene over plus 1 methylphenanthrene and 9 methylphenanthrene. So you should find the location or where these compounds are elucidated from the chromatograph. So later on you will find each type of methylphenanthrene and you calculate the data. So you put the data on the Excel sheet for later on. So these data can be used in any time, in any methods, or in any ways to compare between these results. So it's just, I mentioned quickly about these isomers, and there are many other parameters to be done. One of the parameters, or one of the simple for correlation, is the shape or the envelope of chromatograms or from the GC. You can see it is unimodal or bimodal, and it is indicate of maturity or immature. So you will prepare that samples for oils. Yeah, these samples for oils. Well, K252 and Jambur 15. You see that the results nearly the same. You can elucidate, you can calculate each carbon from the 14, 16 to what you have. So there are some agreement or similarity between, maybe you have similarity or maybe there are differences. When you have similarity in composition and degree of maturation is also from the envelope of chromatograms or GC results, you will find that it is like each other or maybe different. Also, we can use 24 normal properly co-stain index, as we said. It is one of the isomers of stearins. You can follow it. You can follow it using 217 MZ, and later on you will find properly co-stain, because we said we have co-stain, methyl co-stain, ethyl co-stain, and later properly co-stain here. And these are very good indicator. Not very not common in, or I didn't talk about the more similarity. These are maybe in many of source logs or soils are the same. So I put these samples, and we see later on according to regular series, you can see all near each other sample. So in general, the analyzed samples for oils are nearly the same or are from the same origin. Oil source correlation. Also, we can use the shape of chromatograms, or as we say, it is the envelope of chromatograms. Here, that is okay. It's similar to this, but here we have different type. So it's not like it. It is different from this type. That one is from Hameen web. So we appear that there is a different or difference or the not similarity between these results. Total from aromatics also. I put this just for comparison for this. We have some problems about aromatics. They need more working here because we have a hump here, unresolved complex here. But we see in the Hameen, we see a different aromatics or very little aromatics. So another fragment is selected. I am noting using 217. Also, we have the propylcholine here. Also, we use it, and we see it is here. Yeah, we have some, but it was very small if compared with other wells or other results. So rock extracts are good, but with this Hameen we have some problems here. Alkylation patterns also, you can use it for dibenzethiophene type of alkaline. You can follow it by using 148, 84, sorry, 198, and also 212 chromatograms for ML/Z, and you will find some similarity between the rocks and rock extracts and oils and different, or that's from oil 200K252. Still internally also, we put it or we plot it, the results here in the stirring or regular stirrings. We saw that there are some the samples or the rock samples are not exactly the same, but at last we conclude that these rocks maybe the source, the Chiagara formation is, I don't guess that it is only the source, but it is, without a doubt, it is one of the sources. Maybe there is another source, but Chiagara formation is one of the sources that can be defined as a source of these oils in different using biomarkers, using dynamic in the oils. That's what we have here, and thank you very much.
Thank you very much, Dr. Bain. Any questions, please? Which one is the Oscar?
One of the things about stratigraphy. Okay, well online. I don't know how sure you are about the existence of Barcelona formation over there. It has, I think, over there, the section 283 meters belong to Barcelona and a few meters, which is blacky, very blacky bituminous shale, maybe belong to Sergalo or Naukelakan, or Najma formation. My point is that the whole Chamchamar, it's like a border between Gutnia and Barcelona, Najma and Naukelakan. We didn't see at all over all Kurdistan, Barcelona exists 30-35 meters. How come in Kirkuk, which is, we know that during Cambridgian, Carovian Cambridgian,